So today we'll be talking about photosynthesis, and there is one of two reactions that start. The first one we'll be talking about today is the light-dependent reaction, and obviously it makes up chloroplast, and within the chloroplast there is grana, and grana are basically groups of thylakoid, and we'll just be talking about only one thylakoid that creates ATP and NADPH. So when it starts, we do photolysis, where light, which is coming from the sun, comes down and breaks down the water, H2O, and this is being oxidized because it's losing its hydrogen. While this happens, it loses the electrons, and so hydrogens in here are known as ions, because the electrons is going into this protein, which is known as photosystem 2. It enters the reaction center, and in order for it to work, or for it to start working in these proteins, the light from the sun, known as photons, enter photosystem 2 and excites the chlorophyll, which are these little purple dots, until it reaches the reaction center. And because of that, the electrons will jump from this protein to the other until it hits this transport membrane, where it gets the concentration of the hydrogen outside of the stroma into the thylakoid space. And as this happens, this is where photosystem 2's purpose comes in, where it creates ATP. So because of the thylakoid space having a lot of hydrogen, or a high concentration gradient state of hydrogen, it'll go to the ATP synthase, which is down here, and through facilitated diffusion will go down, and it will reaction for the ADP plus the phosphate to create ATP.
I'm applying at MIT, she said, like, yeah, I could apply at MIT, yeah. I'm at MIT. I think I'm going to go.
Okay, so once this one's done, the electrons here will continue down their path from one protein to the other, and now it's hit photosystem 1. Because of hitting this protein, it's lost its energy to react. So then photons from the sun will come back to photosystem 1 and excite the chlorophyll until it hits the reaction center with the electrons, and it'll go to NADP reductase. In NADP reductase, it creates NADPH by causing a reaction where the NADP will reduce and combine with hydrogen. So because of the hydrogen coming from the ATP synthase, it'll come up here, and the electrons will combine with the ions of hydrogen and create NADPH. And so the products from this reaction is ATP, NADPH, and those will be used for the Calvin cycle.